Hi, did you know EDEXCEL made practice papers? Well, they do, and they're a fantastic resource. They are full sets, papers 1, 2, and 3, and 80 marks on each. So, how many have they actually made? Loads. I mean, loads. There are 144. I don't think anybody would need that many. Anyway, I am making it my mission to do worked solutions for as many as I can. Obviously, the goal is all 144. I do work full time though, so I'm going to be creating them and pushing them out as quickly as I can. So watch the channel because new videos are going to land all the time. Now, to use the papers, I would recommend downloading them, sitting quietly, cracking on with it, and then coming back to do the marking. You've got all the solutions with walkthrough examples. So if anything's gone wrong and you need to see the steps in the methods, it's all going to be there for you. Now, for grade boundaries on the end screen, I've provided some percentages as guide only. No one knows what the grade boundaries will be ever. Anyone telling you are really just trying to give you a guide, and mine is no different. I have gone for the highest percentages we've seen so that we are reducing our risks, but it gives you a goal. It gives you something to head for. And I think that is really, really useful. So once you've got your score, check out the end screen, and that will also give you an idea of your grade. Now, if you're really struggling, if you're finding that you're sitting down to do the papers and they're not going very well, but you like the way that I explain and walk through the questions, then I do have some courses that are available. They are in the description below, so you can just click on that link. If you are somebody that wants to be studying and gaining the higher grades, my grade 6 course is currently free here on the channel. So do go and check that out. The course is designed to help you develop your critical thinking skills. So whilst it's all labeled up as grade 6, because we use a lot of those topics to help us, actually what you're going to really get from that is those topics, but the critical skills that you need. Okay, well, good luck with your studies. This will make a great addition to your revision. If you like what we're doing, please hit that like and subscribe button. That'll hopefully push the video out to more people and more people can benefit from it. Obviously, comments are great. So yeah, just good luck. Revising for a GCSE maths, it's going to be tough. So I wish you well. Okay, our first question is a long multiplication. Now, most higher students would probably use the traditional method. Remember, just ignore your decimals to start off with. There are obviously other methods, and you will use whichever one you feel most confident with. Once you've got your digits, then you can start thinking about where that decimal is going to go. Now, we can see that the 54 we used was actually divided by 10 for 5.4, so we'll come in one place, and our 24 was actually a division of 100, so in two places to give us 1.296 for our final answer. Okay, our next question is a crossover question seen on both foundation and higher. It's an error interval, which has been set up for us, so we just need to find the missing values. I like to do this thinking about a number line. So we've been given 72 that's been rounded to the nearest centimetre. So the next centimetre would have been 73, the one before 71, and we want those values slap bang in the middle. So 71.5 and 72.5. Okay, another crossover. So we have got lots of information, actually. It's quite wordy. We've got a diagram. We're being told that the depth of the orange juice in the carton is 8 centimetres. So technically, whilst it's 20 centimetres tall, we're only looking at orange juice that's filled up to 8 centimetres. So this kind of capacity here. So we want to find the volume at this point. So the base is 6 times 10, times that through by the height of 8, and you would end up with 480 480. So we know that there are 480 cubic centimeters in the carton. Now, when we flip it, we will, and this takes a little bit of visualizing, we will have 6 along the bottom and 20, and we will be 10 high. And I could put a little bit more into my diagram so that I can kind of see the carton a little bit. I find drawing and modeling a really important part of my problem solving. I would encourage everybody to do it. Now I'm going to do my 20 times 6, which is 120. I know that my total capacity is 480, which I'm going to divide through by the 120. Cancel that. 12 into 48 equals 4. So the depth in my new carton is going to be 4 centimeters. And that is my final answer. Now, you could have spotted that the 6 and the 10 had changed to the 6 and the 20. So it's a half in its difference. But that's a walkthrough of actually thinking about each step as a process. So I hope that has been helpful. Question 4, we've got to write these in order of size with the smallest first. And we need to get these so that they are all written in a similar, same way so that we can actually make that comparison. So we're going to turn all of these into ordinary numbers and then we can compare. 10 to the 2 is timesing by 100. That would give me 3.8. We've got times 10 to the negative 4. That means our decimal point, which is currently on the end, is going to move 4 places to create that decimal. Obviously, 380 is 380. It's already ordinary. And then again, we just need to move 1 place because of that negative power to give us 0.038. Once we've got that, we can clearly see that this one is our smallest, followed by this one, and this, then this. So we just need to write that out. Okay, another crossover, both seen on foundation and higher. We're being asked to translate shape P by the vector 5, -2. Now, a translation slides, and the vector gives the direction that you need to go in. So a positive 5 means we will be going 5 forward, and that negative means we're going to be going down 2. So I have chosen this corner to count from, which takes me here. And now I'm going to make sure that I grow as I draw the shape. I'm going to grow it from that corner. And that's our translation. Okay, the next part of this is to describe the single transformation. And we can see straight away that this isn't going to be a translation. It hasn't slid into place. So it's either going to be a reflection or a rotation. And we can use our tracing paper to help us with this. Now, my software is not fantastic, but I can certainly help you get an idea of how you would do this. So you would take the tracing paper, you would trace your shape, and take the time to be fairly accurate here. And then you would use your pencil to stab at the origin, and you hold your pencil at that point, and then you can twist the tracing paper with it pinned to the page. As you twist it, you are looking to see if it will land exactly on top. Now, when you twist that, it doesn't quite land on top, but it does take the shape after you've done half a turn. So it's definitely a rotation. It's just not at that exact point. So then you would move out to these other points that go around the origin. And basically, you will just be testing one at a time until you find the one that positions it exactly on top. And that would be 0, 1. So we will write down that it's a rotation 180 degrees in the point 0, 1. Now, if we had done that rotation and it hadn't looked already in that same position, just slightly off, if it was completely different, then you know to rule the rotation out and to then start looking for that mirror line and work out what the reflection would have been. But in this case, as we can see, it's a rotation. Okay, another crossover question. Now, it would be incredibly tempting to expand this, but we're being asked to simplify, which means we need to create a tidier, sort of smaller version of this algebra. And to do that, we really want to see that the x plus 2 that's being multiplied by itself is expanded to show that, but don't take it any further. Don't crab's claw it, because then we can take 1 from the top to cancel the bottom and simplify it to x plus 2. Here we're going to use our indice rules. Going to do the number work first. So 2 times 3 is 6. Then we've got a squared times a cubed. We add the powers for a multiplication question. And then we've got b times b, which is b squared. Okay, next question is another crossover, so on both foundation and higher. In this question, we've been given some information about a concrete mix. So we've got a ratio of cement, sand, and gravel, and together that will create our concrete. So let's first of all code out this line. I would always code out immediately. So we've got cement, sand, gravel, 1 to 3 to 5. Now that, when it's mixed together, creates concrete. So in the ratio, we would have 9. We added those and just mixed up our concrete in parts 1, 3 to 5, we would have 9. Now he needs to make 180. So we want a total of 180. To get from 9 to 180, we're going to times by 20. So we do that on the opposite side. So that's what he needs. That's what he needs if he's going to create 180 kilograms of concrete mix. What have we got? We've got enough of sand and gravel, but we do not have enough cement. So will he be able to make that mix? No. Okay, our next question, quite wordy. So we need to read through this very carefully so that we can glean the appropriate maths from it. So we've got a full bottle of wallpaper removal, 600 milliliters. And we are going to be using 750 milliliters of water. Now, in the box, we're being told that a quarter is mixed with 400 milliliters. So a quarter of 600, half it and half it again, is 150. So 150 is mixed with 4,500. That's a fact. We only want 750 milliliters of water. So this can be used in that boxes in labels method. If you've seen my videos in the past, you will know all about that. If you haven't, and this is very first video with me, go check out the boxes in labels. It's absolutely brilliant at helping you structure if you're ever a little unsure. So in our boxes and labels method, we multiply across and we divide by the corner. But we've got to remember this is non-calculator. So we need to think of a way of doing this where it doesn't get too tricky. I know that I've got to divide by the one in the corner. I can put the 150 or the 750 as a numerator, and I need to kind of work out which one I think would be best. Now, because I've got a non-calculator, going to use this because it's a smaller number and smaller numbers are generally easier, but also because I can see 15 and 45 and they will go into each other quite nicely. So I can do this, I hope, fairly easily. I'm going to divide through by the 10, first of all. And then I'm going to think, right, how many 15s can I get into 45? Yeah. If I was going to divide by 15, I would end up with 1 on the top. 15s into 45 go 3. And then I've got that 0 left over. So that would give me 1 over 30. The only number I haven't used yet is my 750, and that is multiplied in. So now I've got 750 to divide by 30. I could put it over like this and immediately get rid of those zeros by dividing by 10. And then how many 3s can I get into 75? 25. So 25 milliliters of the wallpaper remover needs to be used. Okay, so back to that boxes and labels, just in case it's your first time. What you could do is show the full problem and then start working on aspects of it. But like I say, if you've not seen it before, I would encourage you to just go and check out the videos on boxes and labels and get a better understanding of what's going on there. And of course, with these types of questions, there is always more than one way to approach it. So if you did something completely different to get your 25, that is, of course, fine. Just make sure everything is communicated really well to your examiner. Okay, our next question, again, a crossover question, is asking us to write down the class interval containing the median, and then we're going to be drawing a frequency polygon. Now, the median we know means middle. To get to the middle, we divide by 2. We've been told there's a total of 60 students, so 60 divided by 2 is equal to 30. So we need to see where 30 is. Now, the first, and I hope I'm going to be able to show this nice and clearly, the first 8 students are here, and they've got 0 to 4 CDs. So my first 8 are here. If I add on the 11 students that have 5 to 9, I will be at a total of 19 students as I stretch my way along the frequency. If I go along the frequency again, I can see I'm going to add in another 9, which is going to take me to 28. But remember, I'm trying to get to 30. So at the moment, I've got myself to a total of 28 students that have between 0 and 14 CDs. My 30 is definitely going to lie in here because I only need a couple more students and there's 14 in this group. So my answer is 15 to 19. Now, when we are drawing a frequency polygon, we are basically drawing a straight line graph. So it's just a fancy name for a straight line graph. We do need to know the coordinates. The coordinates are always the midpoint. So the midpoint of the class width in the table plotted with the frequency. So our first one would be 2, 8. Our next one would be 7, 11, and so on. So you will plot those and then draw the graph. Now, don't forget to draw your lines and do remember to make them straight. I've done one here that's a little bit wibbly and it really stands out. It's not neat, it's not tidy. Try and use your ruler wherever possible on these types of questions. Okay, so our next question, we need to make Q the subject of the formula. First thing I'm going to do is get rid of that bracket. So I'm going to expand that. And now I'm going to work on getting Q completely on its own. So I'm going to move that positive number. It will land as a negative number. And when we tidy all of that up, we get 4 plus 3p. I then just need to divide through by the 5 so that Q is on its own. So Q is equal to 4 plus 3p all over 5. All right, lots of different ways to expand and simplify this. I am just going to use Crab's Claw. So x times x is x squared. And then I've got plus 5x minus 3x. And then that is negative 15. don't forget to multiply. That's the most common mistake I see. Tidy it up, and I've got x squared plus 2x minus 15. Part B, to solve this, we are going to factorize. So I'm going to get my brackets, drop my x. It starts positive, so I can just repeat the signs, and I'm working on 9. 3 and 3 multiplies to make 9, but I can't get an 8 out of that combination. So 9 and 1 are going to be my factors. I want to make a positive 8. So 9 take 1. Now I want this to equal 0. So if this bracket is going to equal 0, x will need to be minus 9. And for this one, x will need to be positive 1. And those are my solutions. Okay. We need to solve the inequality. Don't do anything that you wouldn't do with an equal sign. So your method for solving equations can be used for solving inequalities. First thing I need to do is to get the t's on the same side. So I'm moving the smaller set. That's telling me to take away a t, which is going to give me 2t plus 1 is less than 12. And then I'm going to take the 1 to give me 2t less than 11. And then I'm going to divide through by the 2. So t is a number that is less than 11 over 2, or 5.5. It says that t is a whole number, and I have to write down the largest value of t that satisfies this equation, or this inequality, I should say. It's the exact same inequality we've just worked on. So I don't have to do anything more than just consider my answer here. T is less than 5.5. Now I'm being told it has to be a whole number. And what's the largest value that can take? That would be 5. Okay, we've got a crossover question. So this question was both on the foundation and higher paper. It's very wordy. So the first thing we're going to do is transfer as much information as we can onto the diagram that they've already started for us, so that we've got everything we need to see in the kind of right places. So we know that Raksha is leaving Fullbeck at 10. So I'm going to pop that time on. She drives at an average speed of 40 miles per hour. She wants to get to Hornton at 10:35. And our problem is to work out the speed. That's what I'm trying to achieve. So from the information I can see, I've got my distance and speed here, which means I would be able to find my time. Let's not forget our really useful triangle. I've got distance and speed. So I'm going to be doing 10 divided by 40. If I cancel that down, I can see that's a quarter. And a quarter of an hour is 15 minutes. So this section of the journey has just taken 15 minutes, which means my time is now 10:15. So let's get that marked on. What that does is it helps me get an extra piece of information here. I need to know the time if I'm going to work out the speed. I know it's 10:15 and she wants to be there by 10:35. So we've got 20 minutes. Speed is distance, which is 18 over time. Now, if I put 20 in, that's fine, but I do need to remember that this is in minutes. And actually, I want to be in miles per hour. So I'm going to times this through by 3 to give me 54 over 60. And now what I've got is 54 miles per hour, because obviously this is 54 out of 60 minutes, or it's 54 out of an hour. So that is my final answer. Okay, our next question. We're being told that m is directly proportional to L cubed. That leads to the equation m equals KL cubed. And now we can just substitute in the information that they've given us. M is 160. L is 2, which is going to lead to 8K, giving us K as 20. Once I found out what k is, I can then write the equation with that k gone. I've got to find the value of m when L is 3. So all I need to do now is change my L to 3, which is going to give me 20 times 27. Well, if I double my 27, I get 54, add the 0, and that is my final answer. Okay, so we are looking at a histogram. That is our keyword. We want our keyword to trigger this formula triangle because it will help us. Frequency, frequency density, and class width. Okay, we can see from the table that we've got our frequency. Our class width is here. So we're going to add an extra column for frequency density because we don't have any values on this scale, which is our frequency density scale. So we're going to use the triangle to help us work out the scale. So in the first row, we have a frequency of 15. We need to divide that by the class width, which is 5, and that gives 3. So the height of our 0 to 5, the height of that is 3. And once I've got that, I can see what the scale is, and I can add in all those additional numbers. So I've got it, I can see it. I've got to use the information in the histogram to complete the table and eventually complete the histogram itself. So let's get to work on our 10 to 20. Our 10 to 20 has a height of 2.5. So that is the frequency density. To find the frequency, we multiply that by the class width, and that will give us 25 in the table. The height of our 20 to 40 is 0.8. So that's our frequency density. Times that by our class width, which is 20, and we get 16. Now, to complete the histogram, we will do our frequency, divide it through by the class width. That is going to be a half, or 0.5. So I am going to draw my bar at 0.5 across to the 60. Okay, our next question. We've got an indice, 49 to the power of a half. We need to know that the denominator of the fraction is what we root by, and the numerator is our power. So this is a really simple one. We're just going to square root 49 to give us 7. Now, technically, it's plus and minus 7. However, they're going to accept 7, so don't worry too much about that. We need to simplify the surd. So we're just going to split. What multiplies to make 45? We've got 9 and 5, and they split into roots. Don't lose the square root signs. One way to do this is to keep going and keep splitting until you've got the prime number. So it has that kind of prime factor feel, that method that we use for prime factors. Now, when you've got 2 that are the same, it cancels the root out and it creates just the number inside. So we've got 3 root 5 as our final answer. Other students are very confident with their surds. They'll spot the square number and they'll just turn that into the 3 immediately. But this is a nice method for anyone that feels they get muddled. Okay, so question 17 is asking us to prove algebraically. So we must use algebra to show that x can be written as this. I quite like these types of questions because it's given us the answer. It's given us our goal. So we know what we want to achieve. First thing is we're going to just expand this decimal so we can see a little bit of it. By doing that, we can see that it takes 2 place values for it to repeat. That tells me that I'm going to multiply everything by 100. That's the left-hand side and the right-hand side. And then we're into the method where we take away an x. We know that x is equal to 0.0454 and on it goes. We can see that these are all lined up, which is what we're looking for. They cancel each other out. And when I do my takeaway, I got 99x equaling 4.5. So we're going to divide through by the 99. We want to get rid of the decimal, so times that through. And we end up with, this is our fraction. Now that should equal 1 over 22. You could assume it does and move on to the next question, but I wouldn't recommend that. We will quickly check using division. So 990, divide that through by 45. 45s into 9 obviously don't go. Into 99 will go 2, remainder 9, and into 90 goes 2 again. So I've double checked it works. It does. We'll divide the fraction by 45 and it gives us 1 over 22. Okay, so we've got to enlarge this shape by a scale factor of -1.5 or -1.5, whichever you want to work in. We're being told that the center is 0, 4, so I'm going to mark that on first of all. Now, I like to use the vectors method for enlargement. I find it way easier than messing around with rays, although you do need your rays if you're describing. So the vector to go from my center 0, 4 to this corner of the shape would be 2, 2. I'm going to times that through by the scale factor, which is -1.5. And that is going to give me the result -3, -3. So I'm going to go back to my center and I'm going to do the vector that I have just created. So I'm doing -3, -3, and I end up with that coordinate there. I'm then going to repeat this for every single corner. So I'm going to work out my vector to this corner and times it by 1.5, and also to this corner, timesing it by, negative -1.5, and then I will plot all those corners. Once I've got all my corners, all I need to do now is draw in the shape. And that is enlargement by vector notation. Honestly, best way, in my opinion, for what it's worth. Our next question is a probability question, and we've got to work out the probability that she takes 2 different types of sandwiches. Well, we really need to build a picture of all those combinations that she can take. So we're going to use the tree diagram, and we're going to say, okay, if she was to take an egg first, she could then take another egg, or a cheese, or a ham. And that's one of my combinations. Equally, she could have taken a cheese. And then one of the following. And notice how I'm keeping them in order. I don't want to kind of change it up too much. Otherwise, it starts to get a little bit confusing. And I don't want to do that. I want to keep things in a nice order. Now, you'll notice that I haven't joined these. It's just a personal preference. You could join them so that they look like a proper tree diagram. Now, we want 2 different types. So if we take a look at what we've just drawn, that means it could be egg with the cheese or the ham, cheese with the egg or the ham, or ham with the egg and the cheese. And that is 6 combinations and 6 calculations that I will need to do. And I'm too lazy for this. So I'm going to find the ones that I don't want, because there's only 3 of them. The probability of getting an egg sandwich is 4 out of 11. The probability of me taking another egg would be 3, because there's only 3 left, out of 10, because there are only 10 sandwiches left. So to get an egg-egg combination, it would be 4 over 11. I don't know why I put a H on that 11. And that will give us 12 over 110. Sometimes I do silly things. Okay, we're going to do cheese next. And now the ham. Okay, now we've got to remember, these are actually the probabilities I don't want. I'm going to add them together, which is going to give me 34 over 110. If that's the probability I don't want, then the probability that I do want is going to be 1, take away. So this is the shortcut, really. That would lead to 76 over 110. I could have just found all 6 combinations, done all the maths, added them together, and I would have got to that 76 over 110 that way. And it's personal preference, I think, with these probability tree diagrams. But if you know you want the opposite, that one takeaway can be a really useful thing. Okay, so we've been given some coordinates. We've got a straight line already on our grid. We're being asked to find the equation of the line that passes through C and is perpendicular to AB. So I think the first thing I'd do is draw that line on. I want to visually see it. So I'm going to pop that on. It doesn't have to be perfect. I'm going to pop on the 90-degree angle that perpendicular gives so that it's there. I can see it. It's in my eye line. And I've got to find the equation of that line. I have got a coordinate because they've told me that C is 5 minus 1. So I have that. All I need now is a gradient to go with it. I am going to get the gradient of the line AB, and then I can use that to help me. I'm going to use the gradient formula, m equals y2 minus y1 over x2 minus x1. That will lead to 4 minus 0 over 0 minus minus 2. And if you need to, you could always label up these with the subscripts y2, y1, so that it's just easier to make that substitution. When we do the maths that creates, we end up with 4 over 2, which is 2. So I know the gradient of this line is 2. A perpendicular gradient is going to be negative a half. It's the reciprocal and the opposite sign always. All right. Now I know my gradient and I have a coordinate. I can use the formula y minus y1 equals mx minus x1. So I've got y minus negative 1 equaling minus half x minus 5. Expand all of this out. That will create a positive. Don't miss that. It's easy to do. And then obviously I'm just going to pop that 1. It's going to land as a takeaway 1. And when we work through the maths that gives, we end up with minus a half x plus 3 over 2. And that is our answer. I particularly like this formula because it makes everything really, really easy. And it's also the formula that you would use if you were going to go on and study further maths at A level post GCSE. And to be familiar with this earlier rather than later is always better. But of course, it isn't the only way that you can do it. You could just use your y equals mx plus c and work it through that way instead. Okay, so we're looking at a circle equation where its center is at the origin. So I've marked that on. And this part here is the radius squared. So if I just square root 9, that is going to give me the radius. So I know that my circle will have a radius of 3. I'm being asked to construct the graph. So all I'm going to do is get my compass, stretch it onto my ruler so that I know that the difference between the arms or the gap between the arms is 3 centimeters. Then I'm going to stab the center and I'm going to draw the circle. So for part B, we need to draw the line x plus y equals 1. Now you can either rearrange your equation to y equals 1 minus x, Or you can consider your X and your Y coordinates so that they give you 1. Either way would work. So if I was plotting -2, for example, on the X, I would need 3 to equal the 1. So I know that would be a coordinate of the line. Equally, if I had 3 on the X coordinate, I would have -2 on the Y coordinate, which isn't always easy on these practice papers. They're not the best grids. And then you just draw your line through. To solve the equations, we really just need to look at where they are crossing. So you just read from the X and the Y to those coordinates, and they will give you the solutions. So when X is equal to -1.6, Y is equal to 2.6. And then when X is equal to 2.6, our Y is equal to -1.6. Okay, our next question. We're being told that two solid shapes, A and B, are mathematically similar. And that's the key word here. As soon as you read similar, you want to be writing scale factor squared, and scale factor cubed. You are going to use scale factor for length. This is area, and this is volume. The base of the shape is a circle with radius 4. We can see that. And the base of the shape B has a radius 8. Now, these are lengths, and they are going to be connected by the scale factor. And it's very simple and straightforward. It's going to be a scale factor of 2. We're told that the surface of shape A, the surface area, is 80 centimeters squared. And we've got to work out the surface area of shape B. So this is nice and straightforward because all we have to do is say it's shape A times scale factor squared equals B. So we've got 80 times by 2 squared, because our scale factor is 2, remember? So we'll be doing 2 squared, which is 4. 8 fours are 32. Add your 0. And our answer is 320 centimeters squared. Now, the second part of this question is asking us to find the volume of A, given that shape B is 600. Now, this works in exactly the same way. Just think of it as A multiplied by our scale factor cubed this time, because we're doing the volume, equals B. 2 squared is 8. B is 600. So something times by 8 will give us 600. So we just need to do 600 divided by 8. So 8's into 60. Well, 8's into 6 don't go. Follow it through into the 60. That will go 7, remainder 4. And 8's into 40 go 5. So our answer for that one is, and I'll just pop it here, 75 centimeters cubed. This is the magic without a doubt, guys. This is the magic. So get that keyword to trigger this. Okay, last question. So we've been given a lot of information and we're being asked to prove that ABCD is a rectangle. Now, the first thing that I would do is I would check in line by line, and if I can add anything they're telling me to my diagram, I will. So it says A and D are 2 points on the circumference of a circle. So A and D are 2 points on that larger circle, and then A and B are 2 points on the smaller. So I'm going to mark those points. DB and AC are tangents to both circles. What do I know about tangents and circles in my world of circle theorems? I know that tangents from an external point are equal. So I'm going to mark that on. Those two lengths there going to E to D and E to A, they will be equal because of that circle theorem. And I can also write that down. DE is equal to AE. But these are tangents to both circles, which means that EB is also equal to AE. So I now know that all of these lengths are equal. Now I'm going to pop on my rectangle so that I can start to see that a little bit better. It's only a sketch. It won't be perfect. And it may not look like a perfect rectangle either. The only edge that I don't have any information about is EC. However, it does say that E is the midpoint of AC. So if this is the midpoint here of this line, then I've just shown that this is also equal to this. So now I've got all four of these equal. These are the diagonals of my rectangle. If the diagonals are equal and they bisect, which they do, then we have that proof. So we just need to write that down. And that's our proof. Now, it's not the only way to do it. You could have explored the fact that you've got isosceles triangles going on here. And you could have used that as your walk around the problem. So this is not the only way that you could prove it. And that's it. Some proper tricky questions in that paper. So I hope the work solutions have been useful. I look forward to seeing you in some of our other videos. We're going to be making a lot of these practice papers. So keep an eye on the channel. If you like what we're doing, please like and subscribe, because obviously it really helps my little channel grow. And yeah, hopefully I'll see you in the next one.